Dear student, welcome to my channel Mahendra Mechanical. Today I am going to cover the topic production system and computer integrated manufacturing. What is production system and what is computer integrated manufacturing? First, what is the concept of the manufacturing? If we say that manufacturing is the process in which we convert the raw material into the useful product by using machine, tool, labor, power. Manufacturing can also be defined as the application of physical and chemical process to alter the geometry, property, and or appearance of a given starting material to make parts or products. Manufacturing also includes the joining of multiple parts to make assembled product. The process that accomplishes manufacturing involve a combination of machinery, tools, power, and manual labor. Concept of manufacturing. This is the starting material and here manufacturing process took place. Material in processing, value added, and here complete part or product. Manufacturing is almost always carried out as a sequence of operation. Here, not only single operation, lots of operation performed on the product. Each successive operation bring the material closer to the desired final state. From an economic viewpoint, manufacturing is the transformation of material into items of greater value by means of one or more processing and or assembly operation. So if you are saying from the economic point of view, then manufacturing is the process which increase the value of the product. The key point is that manufacturing adds value to the material by changing its shape or property or by combining it with other materials that have been similarly altered. The material has been made more valuable through the manufacturing operation performed on it. So in the workshop, you can see lots of machine, drilling machine, lathe machine, shaper, planer, milling machine. In lots different types of milling machine, different types of lathe machine, general purpose lathe machine, capacitor and turret lathe machine. In drilling, you can also see lots of drilling machine, radial drill radial drill having large size and small drill, different types of grinding machine. So if you are moving towards making product, then first will be the casting process. After that, from casting the dimensional accuracy is not that much good and surface finish is also poor, then by machining we can get good dimensional accuracy and surface finish. This is the classification of manufacturing process. Manufacturing process first classify into processing operation and assembly operation. Processing operation further classified into three forms: shaping process, property enhancing, surface processing. Shaping process means we are going to change the shape. The first one is the solidification process, which is a casting process. Particulate processing, we work on the powder form of the material. It is also known as powder metallurgy. Deformation process, we apply the force on the material to change its shape and property. The farming operation comes into under farming lots of operation like forging, rolling, extrusion. Next is the metal removal process in which the machining, lathe machine, milling machine, drilling machine, and another types of some unconventional machine, laser beam machining, plasma arc machining. Property enhancing is the heat treatment. If you want to increase the turf toughness, if you want to make the surface of the material to more hardened, then case hardening. So by using different heat treatment, we can increase the property of the material. We can increase the ductility, we can increase the hardness, we can increase the toughness, we can increase the brittleness. So these are the property enhancing process. Next is the surface processing, cleaning and surface treating, coating and deposition. If you want to make the surface is having different property and inside bulk material is having different property, suppose you want to make a tool for machining the super alloy like nickel based super alloy, then our base material bulk material should be tungsten carbide having different property, and the surface of the tool should have different property. So by using the coating, PVD coating, CVD coating, different layers, titanium nitride, titanium aluminum nitride, Al2O3, titanium carbide nitride, ceramics, different types of ceramic layer you can provide which is having good anti-friction property and good thermal stability. Next, we are moving towards assembly operation, which we further classified into joining process and mechanical fastening. Joining process further classified welding, brazing and soldering, adhesive bonding. Mechanical fastening, threaded fastener and permanent fastening. So these are the some mechanical fastening and this is the joining process. Next, I am moving further. You can see lots of picture. First one is the casting process. Molten metal is poured from the crucible to the mold cavity. Second, here you can see machining process where chip is removing by using single point cutting tool in the lathe machining operation. Shaping operation, solidification, particulate processing, deformation process, material removal process, property enhancing operation, heat treatment, surface processing operation, cleaning and surface treatment, coating and thin film deposition. Assembly operation, here you can see lots of rivet, threaded fastener, nut bolt type. The joining process, building, brazing and soldering, adhesive bonding by using sub-adhesive. Mechanical assembly, threaded fastener, example, bolt and nut, screw, rivet, interference fit, press fit, shrink fit, others. Here in the figure you can see the arc building process. Some worker by providing the shielding, by bearing the shielding, they are doing the shielded metal arc welding process. Here fume generated. That's why for eye protection he used this shield. Next, material handling. How we handle the material during the processing. Material transport, we use vehicles. Example, forklift, truck, monorails, AGV, conveyor. Conveyor is used for transferring material from one machine to another machine. Hoist and cranes for heavy items to replace from one location to another for doing different operation. We use cranes. Storage system, unitizing equipment, automatic identification and data capture. Then last is the barcode, RFID, other AIDC. This is automatic identification and data capture. This is the time spent in material handling. During manufacturing process, if time on the machine is 5%, then 95% time goes into moving and waiting. This is the situation inside the factory. Next, time spent on the machine 5% will goes into 30% into cutting and 70% into loading, positioning, etc. So this is the time spent in material handling during manufacturing process. This is a production system. What is production system? A collection of people, equipment and procedure organized to accomplish the manufacturing operation of a company. So this is a production system. In production system, there is a two part. One is the factory equipment facilities and another is the manufacturing support system. So this system support the manufacturing. The production system works in two part. One is the factory equipment facilities, another one is the supporting unit. Next, this is the factory and equipment. Here you can see different types of robotics used in different types of building and processing. Manufacturing support system. Here facilities, what are the machines, what are the tools, what robots, different types of. Next here support system. Business function, sales and marketing, order entry, cost accounting, customer billing, product design, research and development, design engineering, prototype shop. So this is a project design, manufacturing planning, process planning, production planning, material resource planning, capacity planning, manufacturing control, shop floor control, inventory control, quality control. So these are the things which comes under manufacturing support system. Manufacturing support system you can see in this figure. Information processing cycle in a typical manufacturing firm. Product design transfer to manufacturing planning, manufacturing planning transfer to manufacturing control, and manufacturing control transfer to business function. And in business function, customer order is the input. How much customer order company got, then on that basis what features customer required, the product design will start, and this will supply to a production system facilities where processing will happen. Computer integrated manufacturing. Here some more things comes into the picture. This is the computer use of computer during the manufacturing system. Potential computerized application, potential automation application. So by using these two things, manufacturing goes towards computer integrated manufacturing. Product variety versus product quantity. How much variety you need and how much quantity you need. If variety is less, then quantity will be high. If variety is more, if you need lots of varieties, then quantity will be less. If suppose you want to make a single variety, then product quantity will be very high. So this is the graph between product variety and product quantity. Low production quantity. Low production quantity is known as job shop. Makes low quantity of specialized and customized product. Products are typically complex. Example, specialized machinery, prototype, space capsule. Equipment is general purpose. Plant layout, fixed position layout, process layout. This is the low production quantity. Next, this is also known as fixed position layout. Here you can see the manufacturing of the aircraft. So this is a fixed position layout. Our aircraft is fixed at one position, and by going all the machine into that position, the operation will be performed. This is a process layout. Worker, this is a worker, this is a machine workstation, and process, Suppose here you want to do the casting, then next you want to do machining, then you want to do building, after that you want to do grinding operation, and next packaging operation. So this is a process layout. Medium production quantity, batch production. A batch of a given product is produced and then the facility is changed over to produce another product. Changeover take time, setup time, typical layout, process layout, hard product variety. Here you cannot get large variety. Cellular manufacturing, a mixture of product is made without significant change over time between product. Typical layout, cellular layout, soft product variety. This is the cellular layout workflows from one machine to another in a circular way. High production, quantity production, not the feature is not very variety is not very high. Equipment is dedicated to the manufacture of one product. Standard machine tool for high production. Example, stamping process, molding machine. Typical layout, process layout, flow line production, multiple workstation arranged in sequence. Product require multiple processing or assembly steps. Product layout is most common. This is a product layout. Only one product is made. Worker in station, workflow from one location to another. This is the PQ relationship, product variety and product quantity. Fixed position layout having the high variety. Next, batch production is having the medium variety and medium production, and product layout is the mass production. Product quantity, number of unit of a given part or product produced annually by the plant. Three quantity range, low production 1 to 100 unit, medium production 100 to 10,000 unit, and high production 10,000 to million of unit. Next, product variety, number of different product or part design or types. Hard product variety, product differ greatly, few common component in an assembly. Soft product variety, small difference between product. Hard variety produces different greatly many common component in an assembly. Product quantity and variety, let Q is equal to annual quantity of variety, P variety of product from 1 to J, total number of product unit. Product and part complexity, product complexity NP, number of component in product, part complexity, number of processing operation per part. Product complexity, number of component in product, part complexity, number of processing operation per part. This is the some figure. Number of component product, mechanical pencil 10, ball bearing 20, rifle 50, sewing machine 150, bicycle chain 300, bicycle modern 750, early automobile 2000, automobile 20,000, commercial airplane 1 lakh, commercial airplane moderns 10 lakh, space shuttle modern 1 crore. This is the parts approx number of processing operation. Plastic molded part 1, injection molding, washer, stainless steel, stamping, washer, stamping, electroplating, forged part, heating, forging, trimming, pump shaft, machining from bar stock, coated carbide, cutting tool, pressing, centering, coating, grinding, pump housing, casting machining, V6 engine block integrated circuit chip, photolithography, various thermal and chemical process. So this is the some product and their requirement, and typical processing operation used. Factory operation model: total number of product unit P into Q, product variety multiplied by product quantity, total number of parts produced PQNP, total number of operation PQNPNO. Manual work system: hand tool often use worker, starting work unit, process happen, completed work unit. Worker machine system: machine, worker, starting unit, process, completed work unit. Automated system: periodic worker attention, automated machine, starting work unit, process, completed work unit. Automated system: periodic worker, automated system, transformation process. Automated machine tool, transfer line, automated assembly line system, industrial robot. Automated material handling and storage system, automobile automatic inspection system for quality control. So these are the automated system. Fixed automated automation: sequence of processing operation is fixed by the equipment configuration. Typical features: suited to high production quantity, high initial investment for custom engineered equipment, high production rates, relatively inflexible in accommodating product variety. Programmable automation: capability to change the sequence of operation through reprogramming to accommodate different product configuration. Typical feature: high investment in programmable equipment, lower production rate than fixed automation, flexibility to deal with variation and changes in product configuration, more suitable for batch production, physical setup and part program must be changed between jobs. Flexible automation: system is capable of changing over from one job to the next with little lost time between jobs. Typical features: high investment for custom engineered system, continuous production of variable mix of product, medium production rate, flexible to deal with short product variety. Three automation system: programmable automation, flexible automation, fixed automation. This is a variety, this is a quantity. Reason for automating: to increase productivity, to reduce labor cost, to mitigate the effect of labor shortage, to reduce or remove routine manual and clerical tasks, to improve worker safety, to improve product quantity, to reduce manufacturing lead time, to accomplish what cannot be done manually, to avoid the high cost of non-automating. Manual labor in production system: is there a place for manual labor in the modern production system? Yes. Two aspects: manual labor in factory operation, labor in manufacturing support system. Manual labor in factory operation. The long-term term is toward greater use of automated system to substitute for manual labor. When is manual labor justified? Some countries have very low labor rate and automation cannot be justified. Task is too technologically difficult to automate. Short product life cycle, customized product require human flexibility to cope with ups and downs in demand to reduce risk of product failure. Are the some reason why manual labor is justified. Manual labor in production system, manual labor in factory operation. Is there a place for manual labor in the model? Yes. Manual labor in factory operation, labor in manufacturing support, product designer who bring creativity to design tasks, manufacturing engineer who design the production equipment and tooling and plan the production method and routing, equipment maintenance, programming and computer operation, engineering project work, plant management. Automation principle and strategy. The USA principle: 10 strategy for automation and process improvement. Automation migration strategy. Automation principle: understand the existing process, input output analysis, value chain analysis, charting technique and mathematical modeling. Simplify the process, reduce unnecessary steps and move. Automate the process. 10 strategy for automation and production system. Automation migration strategy. So these are the 10 strategy for automation. Specialization of operation, combined operation, simultaneous operation, integration of operation, increase flexibility, improve material handling and storage, online inspection, process control and optimization, plant operation control, computer integrated manufacturing. Automation migration strategy for introduction of new product. Phase 1 manual production. Single station manned cycles working independently. Advantages quick to set up, low cost tooling. Phase 2 automated production. Single station automated cell operating independently. As demand grows and automation can be justified. Phase 3 automated integrated production. Multi station system with serial operation and automated transfer of work unit between stations. This is the automation migration strategy. Phase 1 starting work unit, manual workstation, material handling, completed work unit. Phase 2 manual handling, automated workstation. A typical automation migration strategy: phase 1 manual production with single independent workstation. Phase 2 automated production station with manual handling between stations. Automated integrated production and automated handling between stations. Introduction to automation. Basic element of an automated system. Advanced automation function. Level of automation. So automation and control technology in the production system. This is the manufacturing support system. This is the facilities. Manufacturing support system. Manufacturing system. Quality control system. This is the factory level. This is the enterprise level. Both combined together make production system. Element of automated system. Electricity, the principal power source. Power to accomplish the automated process. Power for process. Power for automation. Program of instruction. Example CNC part program. During each step, there are one or more activity involving changing in one or more process parameter, temperature setting of a furnace, axis position in a positioning system, motor on off, decision making in a programmed work cycle. Feature of work cycle: program control system, closed loop, open loop, positioning system using feedback control, when to use an open loop control system, advanced automation function, safety monitoring, maintenance and repair, diagnostic, error detection and recovery. Safety monitoring: use of sensor to track the system's operation and identify conditions that are unsafe or potentially unsafe. Reason for safety monitoring: to protect worker and equipment. Possible reason to hazards: complete stoppage of the system, sounding an alarm, reducing operating speed of process, taking corrective action to recover from the safety violation. Maintenance and repair diagnostic, status monitoring, monitoring and record status of key sensor and parameter during system operation. Failure diagnostic involve when a malfunction occur. Purpose: analyze recorded values so the cause of the malfunction can be identified. Recommendation of repair procedure: provide recommended procedure for the repair crew to effect repair. Error detection and recovery. Level of automation: device level, machine level, system level, plant level, enterprise level. Device level: actuator, sensor and other hardware component to form individual control loop for the next level. Machine level: CNC machine tool and similar production system, industrial robot, material handling equipment. Cell or system level: manufacturing cell or system, plant level, factory or production system level, enterprise level, corporate information system. This is level of automation. Inspection and testing. Inspection: conformance to design specification. Inspection for variable. Here you can see in the universal testing machine, ultimate tensile strength, compressive strength, shear strength. Here in by using optical microscope, you can check the microstructure. Observing the product during operation, part, material, sub-assembly, inspection of attribute, gauging. This is inspection and testing. Now we'll moving toward coordination and control. Regulation of the individual processing and assembly operation, process control, quality control, management of plant level activity, production planning and control, quality control, industrial automation architecture. Cycle time has three elements: actual machining time, workpiece handling time, and tool handling time. Rate of production, total batch time per machine, average production time per part. Rate of production 1 divided by TP. Manufacturing lead time, operating time, non-operating time. These are the some lead time, demand rate, work in progress ratio, production concept and mathematical modeling, production rate, production capacity, utilization, availability, manufacturing lead time, work in process. That's all about manufacturing production system. I am going to stop. If you did not subscribe my channel, please subscribe so you can get more useful video.